I'm going to hand over to Will to explain and justify it in a second. But we have really crazy naming conventions like cat and vat and flip and flop and bite. So this is going to be a whole experience. William, what is going on in this diagram?
I think it's fairly self-explanatory. You just follow the arrows and it all works out.
Yeah, that makes sense, dude. Yeah, so good, so chilled.
That being said, the truth is, I think in a way it looks worse than it actually is. I am also improving this, so the truth is, I would have to like sit here and just being like, architecture diagram Friday. But I mean, everything that you've got on the far right or far left are people who are interacting with the system. Those are the circles over there. When you have these arrows, so it's showing you who's calling what, and it has the possible names of the functions that are being called. So for instance, on the right side, 2 circles down, you've got end user going over to, I think that's end in the red box, if I'm not mistaken. So there's a bunch of functions they can call. They can be calling skip or skim or free or all the other ones that I'm not going to bother trying to read because it's actually kind of small on my screen. But yeah. So, I mean, there are a lot of different entries here. I guess we're probably going to have to kind of figure out exactly what we want to look at because, I mean, in an hour, there's no way we're getting through all of this. Oh, yeah. Something you were just pointing out before the call is that there is kind of a certain level of intuition on some of these names. Like there's something called cat that has something to do with liquidations, and the way it liquidates an auction user is the way it liquidates a vault is by an auction user calling a function called byte, which Ben is pointing to right now. And then the VAT calls grab on cat. So it's stuff like is a certain kind of intuition to this. I think one of the things that also has made it kind of famous / infamous in the space is the strange naming convention. I mean, I've seen a lot of people justify it, and in general, what this seems to be is you've kind of got 2 choices when you're doing naming conventions. Either you try and name as intuitively as possible and as loyal to the function as possible, or you just go to the opposite extreme. Because when you're trying to name your functions to some degree, you're building an intuition for somebody reading it as to what the function is supposed to do. That can even hurt in a security sense because you come a bit persuaded by the naming about what's supposed to happen. Free alpha tip, there's a poorly written contract I use sometimes when I'm doing interviews. I have malicious comments in there. Like a comment that says, oh, this is going to whatever. And it's because I'm a horrible person. But aside from that, you do want to see that someone who's reading it doesn't just see the comment, they're like, oh, that's what it's doing, and keep on going. There's a lot of people kind of grief the design choice of naming the functions in the ERC 721 safe transfer and safe transfer. It has nothing to do with being safe. And people think like, oh, this is a more secure way to send an NFT. It has nothing to do with being secure. The goal and the design is that it should check if you're sending to a contract, that contract should signal that it has the functionality for dealing with owning a 721 without it getting blocked there. But it doesn't secure the transfer. And so a lot of people are kind of unhappy with that function name choice. So Maker, when Daps, I believe Dapsys built Maker, Dapsys being the same guys behind Dap Tools and all of that. They kind of went to the opposite extreme and just gave everything like wacky, far-fetched names, because when you see that you're going to frob the VAT, then you don't come in thinking anything other than like, what did those guys eat for breakfast that morning, and where can I buy it?
Yes.
Yeah, I would say without further ado, we can sit here kind of improv, try and figure out how we're going to start looking at this, because we are coming in completely fresh here.
Yeah.
Ben was thinking before that since we memed about the cat and the vat, that we have to see both the cat and the vat. It does look pretty central, it happens to be. We could start with the vat.
Oh, back here. Yeah, that definitely seems like a big deal here. And the cat is just like one of the cuter names I spot here. I think there's also, what else do we have? We have dog, That's pretty cute as
There
well.
is a dog. The cat and the dog fight.
Yeah.
Oh, yeah. There's like a fight there.
There's no cow. Okay, cool, fine.
That's when we have die 3.0. You know?
We'll do a PR for cow. Okay, cool. So let's, I guess, should we start with that?
Start with that. It kind of looks like all roads lead to that. You know what I mean?
Yeah. All right. So here we are in the VAT. Okay, do I need to zoom in a bit? Usually I forget.
Yeah, it'd be good. Solidity 0.6. Interesting.
Nice. If I recall, this was one of the more robust ones that everyone was quite happy to stick with for a while.
Oh, yeah?
I think it was, yeah. Yeah, and then 0.8 came along a bit later.
Mm-hmm.
Anyway. Okay.
So this fix me is interesting. Actually state explicitly that the contract here is altered from what's deployed. Huh. New deployments of this contract will need to include custom events to do. Interesting.
Yeah.
Yeah. Kind of surprised there. I feel like we've seen Linode something else that we looked at. It's like a logging library for like making these kind of generalized events.
This is like, I guess, maybe before. No, so this is on-chain events. This isn't some sort of like hacky thing that they built.
Yeah. Yeah, I am pretty sure.
Yeah.
Yeah.
Okay, cool. Interesting.
Oh, wow. And this also uses the terminology wards. That's interesting.
So, okay, I think we're going to jump back to this diagram a lot. What is a ward?
So it's kind of strange. I'm actually pulling in knowledge from somewhere else recently that I was digging around. There's an infamous MEV bot named 0xA57. If you want to see it on Etherscan, you can look it up as MEV bot 1. We're talking about probably, I don't think there's any address in the entire, actually, to be honest, the entire blockchain that sends more transactions than it. It's nearing 3 million. There was a day where it sent something like 18,000. It actually, it uses a mapping like this, addressed to bool, if I'm not mistaken. I don't think it's addressed to you, and I'm pretty sure it's addressed to bool. That is kind of its mapping for approved addresses. And you'll see over here also it's in an off section. So I think this is a simple whitelist. And it calls them wards. So that's actually why I thought of it, because over there also it uses a public mapping. I believe it's to bool, but it's hard to see because it's not a verified contract. And it's the like kind of whitelist of who can use it, who can utilize the contract's functionality. So I'd assume it's a similar kind of thing here. And the truth is, rely and deny are also there. So I think that maybe 0xA57 was a little bit inspired by Maker. That's like just a funny serendipitous walk away for me, I guess. Rely is the way that you would make you'd add to the whitelist, and deny is to remove from the whitelist.
Oh, that's cool. Yeah, I
wait, really, what's this require though? Require live equals 1.
Well, that's probably just is the contract like paused or disabled?
That not live, probably.
Yeah.
Wards user equal 1 and equals 0. So here it's interesting. They are using 1 and 0 here. It's making me wonder if 0xA57 is actually a bool or if it's a UN256. The reason why I assumed it was a bool is because I seem to remember that it only looks at 2 byte, like a 1 byte, a 2, a 32-word byte.
Yeah, I don't know. What's the benefit here
of doing bool?
Yeah, would a mapping of an address to a bool? I mean, that should use up less.
Be a little bit more costly. Like, is it because you need to put the encoding in for the bool? Maybe.
I don't think.
Yeah, I'm puzzled myself. I'm also a little bit puzzled why they have 2 functions as opposed to 1 function that has a second argument. As in, like, do a generalized function and do the address user and bool status or whatever. And if it's true, you set it to 1, and if it's false, you set it to 0. And you can just do, like, yeah, you can have the same requirement for liveness. So, one other thing I think I'd point out here. First of all, that's like a really funky way to write their solidity. They're actually using inline semicolons over there to get that all in one line, just because it's pretty simple logic. But it's also a minimalist approach to checks. They don't check what the current status is. Like if you would have an address that's already whitelisted and call rely, the function would still run.
Yeah.
It won't stop it just because it's already the status. So there is that kind of expectation that you know what you're doing when you call it.
Yeah. I mean, I think that makes sense. I suppose if it's already, if you're already whitelisted, you're just gonna, I guess, run this again. So you kind of get penalized gas-wise. Like it'll execute and you'll pay a gas because you're penalized for doing something that's redundant. Whereas someone who's actually running it would pay less gas because they'd have to run one less require. So I think that's a good.
Yeah. Modifier based off of that also, so that you can have functions restricted by auth.
Nice. That not authorized. This is the slash thing is interesting. Usually you see it like
colon.
Yeah. This is fine. Nice. Cool. Onwards. It's interesting. Everything's kind of, there's a mapping, then there's two functions, and there's a modifier, then a mapping, then functions. Pretty chaotic.
Right, it's section broken. It reminds me a little bit of like Soulmate Rari code. I'm assuming they actually kind of learned it from Martin and DApp tools, but yeah. As in making by section as opposed to like generalized, like first all your globals and whatever.
Yeah.
It is a little funny to say it reminds me of Rari, just because like Rari is kind of new and Maker is kind of old. That happens to be the order I personally saw them in.
The ancient texts, and also they're like hard to decipher because everything's like bat or a cat or a cow or something. So.
Yeah, Rari, from what I remember, used more normal naming conventions, but you never know. Maybe they'll change their mind about that and start like bliffing to the diffing and all that. Okay, so what's this next section? We have can, hope, nope, and wish. Nested mapping of address to UN. That sounds like an allowance, but like who knows?
An approve allowance thing, yeah.
Yeah.
Can.
Hope sets the can. No, but it's only once in this.
Oh right. So again, it's 1 or 0. Yeah.
Yeah. So it's authorization. It is some kind of authorization. That's what it's doing in auth. I just realized. It's like some kind of authorization. So hope has it set to 1, so then he's authorized. Nope means he's not authorized. And then wish is the view function for seeing if someone is authorized or not. Even though can is public, this one returns a bool, and it's also internal. I wonder why. As in, the mapping's already public. So you could just call that. But then we have this function, wish, which turns it into... Oh, that's got to be some DAppTools function, I'm guessing, either. That's not like a native Solidity function. But basically, it's an or. Either bit equals user or can bit user equals 1. So obviously, if the bit is equal to user, I wonder why it's called the bit. That means it's the user themselves and they're authorized. And otherwise, if can bit user equals 1, it means that bit has approved user as an operator over bits, whatever is being authorized here. And that's also fine. So I guess what it does add is it does add bit equals user, and it gives you a bool as opposed to a UN. Though I don't know how critical it is to get that, like in bool form as opposed to form.
So there's the either. It's like an inline assembly thing to do, just an or logic. That's interesting. So you're passing in 2 booleans, and it'll just be true, or the or of those 2, and you've got both. Okay. This is it's a very artistic way to do code. I'm enjoying it. It's like a fun.
Yeah. Agreed. Oh, and Frob is in the VAT.
Oh wow!
I've been hearing about Frob for ages.
The infamous Frob. Okay.
That not in it. Yeah. Should we go back up? Ilk.
Ilk.
So we have the art, rate, spot, line, and dust. Some of those words actually make sense. My gosh, rate and spot, man. And art has a capital A, which is fascinating to me.
Okay, so art is total normalized debt. What? Okay.
So that's what kind of number it is. There's wads and there's rays. That has to do with fixed point, but I don't remember exactly what it all means. Which I feel is a hopelessly pleb-like thing for me to say, but it's true, so I'll just say it.
But there's all right. Cool.
Yeah, it has to do with DS. I'm like looking this up on the side. Fixed point. Let's see what I got.
More like MakerDAO glossary or something.
There probably is one somewhere. Yeah, they're Maker themselves. What do you know?
Wow. That's awesome, actually. This is great.
Oh, yes, man. Okay, I was actually looking for their docs, so you got it over there, though?
I've got a glossary. I put it in chat. Chat, you can follow along, and you can turn it into doc mode if you want.
Oh, there we go. Ray and Ray are all there. Fixed point integer with 18 decimal places for wad. So that's total normalized debt. So what does total normalized debt mean? Speaking of words that I don't understand.
I mean, I don't know what they mean by normalized. Let's look for art in this case. Where's our VAT? VAT, vault into art. Total normalized stablecoin. What is normalized in this case? Does that mean it's like you've adjusted for interest, maybe?
Maybe even converted, because we have a lot of things from a different rate. Like, you know, we have this much. Yeah, actually, no, that doesn't make much sense, what I just said.
This is the vault engine. Core module. This is so cool. I really want to like go deeper into this.
Yeah, we should someday.
Yeah.
I've been meaning to for years. So. Yeah.
Anyway, I don't know. Like, let's go back, I guess. Okay, so total normalized debt rate. I'm going to keep referring to this. Rate is a stablecoin debt multiplier. Okay, so this accumulates your fees in the rate.
Mm-hmm.
Right. Spot is price with safety margin. Is that the price to mint another like unit of DAI?
Or what you've already done, one of the two, I think. Debt ceiling.
Debt ceiling, that makes sense.
Is this a global? A global thing, I think. The ilk. Maybe there's one ilk per collateral type.
So here's ilks. There's a bytes 32 to an ilk.
Yeah.
So
I suspect there's one ilk for each collateral type.
yeah, that could be it. I mean, you need to have. It doesn't make sense. Well, maybe it does make sense to have like custom vaults.
Multiple ilks.
Yeah, so like for like, let's say an ETH vault to mint DAI. I believe there are like a few different ones that you can do.
Yeah, there are.
Yeah.
Like ETH A, ETH B. Yeah.
Exactly. Yeah.
So you're saying maybe it's even more than one ilk per collateral type. Yeah.
Yeah.
I hear you.
Okay.
I hear you.
I'm guessing that's sort of what we're getting to here. And then there's debt floor. What is
the earn debt floor? I don't know, but the earn is next.
A specific earn is a specific vault, and an ilk is a collateral type.
Oh, okay. So it is one ilk per collateral type, probably, and then there's multiple earns.
Yeah.
You can have multiple earns to an ilk.
I suppose. Let's go back here. So we have a byte 32 to an ilk, and then we can have a byte 32 to address to earn.
I guess that does make sense because it'll just say what the rest of it is. Why was it? I don't know.
Yeah, so
I don't know.
basically, this is probably the identifier.
Hash of something. Yeah.
The ID of an ilk, so that we pass in the same ID of an ilk here, but then we can have multiple addresses that point to multiple urns,
right,
for a given ilk, I guess.
Yeah. And then we have a gem underneath that, which is addressed to uint.
Collateral tokens. Gem is a collateral token.
Yeah, why do we need to redo that in gems, I wonder? If you have the bytes 32, you should probably know what the underlies. Not just that, why do you like specify that in the ilk?
Yeah, I would think.
I feel like I'm missing something.
Right, because an ilk is a collateral type. Collateral type, and then I don't know why you wouldn't save the collateral tokens there, but yeah, I'm sure they've done this by design.
Yeah.
Anyway,
addressed to you in 256 die. Is that balances? This isn't an ERC20 contract. Not exactly sure what they're storing that either.
Interesting. Yeah, I wonder what this address refers to. I don't think it would be. Or maybe it.
It's using a rad, not a wad. Also, I don't think it's a standard ERC20. What's it called? Balance, because the rads were much more decimal places.
Yeah, it doesn't seem to be an ERC20.
It is interesting. All these mappings are public, by the way, because we're out in 0.6 land. Means that they were willing to take the gas hit on that.
This was actually, I didn't notice until now, but like the formatting is quite nice.
Yeah, I was thinking that before also. Their use of tabs I actually really like aesthetically.
Yeah, it's very clean, very readable.
And then a mapping called Sin.
What's that?
It's either sign or it's something to do with debt, I suspect. I'm not sure which.
It's an unbacked stablecoin, so it's system debt, not belonging to.
Okay, so yeah. Simple.
The system debt is sin, dude.
Andean kernel has this big David Graeber thing where, like, the equation of debt and whatnot. It goes through that quite a bit. He's against it. Yeah. Comes to mind very strongly here. Big kernel shout out there. 256 public debt, total die issued. UN 256 Vice, total unbacked die.
Again, Vice and Sin sort of line up.
Oh, because in Sin it's being divided by address. I'm guessing that's what the die mapping is also. It's saying like this particular vault has generated this much die.
Yeah.
I still don't know why that would need a rad as opposed to a wad.
Did we work out between a rad and a wad?
Yeah, it was higher up over here.
Yes.
45 decimal places. Like, why do you need the extra decimal places for something that only has 18 decimals? Like, I agree, adding together, no, subtract. Like, yeah, adding it should never go past 18 decimals.
Yeah, 45 decimals is a lot of decimals, and it's a weird number of decimals. Same for 27. It'd be interesting to know why those were chosen. Anyway.
Yeah, it beats me.
So yeah, we have these globals of total die issued, which is debt, Vice, which is unbacked die issued in the system, line is total debt ceiling.
Total debt ceiling.
Yeah. And then live is we've used that before here. That's just 1 or 0, I think.
Yeah. Yeah. It is interesting to me to use UN 256 instead of Bool. I do seem to remember that there is a gas efficiency with that in a lot of cases. Because with Bool, it needs the encoding also in there, whereas with UN 256, it will like raw just be tons of zeros and a 1.
Could be.
I could be wrong about that. Like you also get that converting smaller UNs into UN 256. Like I think there's all these savings using like UN 128, but then you discover that in a lot of places, if it's not something that can be packed by the compiler, it actually costs you more because it needs the encoding with it.
Yeah, fair enough.
So yeah, message.sender in the constructor gets set as a ward, and then liveness gets set on. That's interesting. It's default on.
Yeah.
So live is really basically like a pause function.
Yeah, that seems to be the case. I wonder.
Technically, they probably could have saved a little bit of gas by doing it the opposite, that 0 is the state where it's unpaused, and 1 is the state where it's paused, because then they wouldn't have 0 to a 1 in the constructor.
True.
But, I mean, that's the small stuff.
Don't you get, isn't there I think this is like one of those obscure things in Solidity where there's like a difference in gas when you're reading a 0 or 1 from storage?
There's something like that. I think the 0 is cheaper.
Is it?
I think the reading 0 is cheaper, if I remember right.
Isn't it? I think 1 might be cheaper because it's a hot slot.
That hot slots, if I remember right, that's just about changing them. To change it to 0 is more expensive. Yeah, if you're writing more, it's more expensive. If you're going from hot, if you've already warmed up a slot and you make it to a non-zero value. Wait, how's it work? Oh, I can't believe I'm forgetting this. This is the whole thing with the reentrancy guard.
Yeah.
Why they do 1 instead of right? Because in the reentrancy guard, you're warming up the slot. If you're writing it back to 0, then you'd be charged more. So if it's a warm slot, you're writing to a non-zero value, you get a partial refund, I seem to remember, from Byzantium and on. OpenZeppelin has it, what's it called? Has it linked.
Sorry, what? You cut out there.
OpenZeppelin actually links to the EIP.
Oh, yeah, this. Anyway, we're getting quite distracted here.
Yeah, there it is. 2200. It's at the
where?
Of the opens up.
Oh, I see. Here we go.
Yeah, you have to be going back to the original value, and I think there has to be no zeros in the middle or something like that.
Net gas metering. This is quite the rabbit hole we're going down here.
But we're trying to save Maker 3 gas.
Yeah. Wow. Okay. I guess let's get back to it. So we've got some math after the constructor. We've got some math. This looks pretty similar to the standard like safe math back in the day. Yeah, we'll skip on past that.
Administration. Yeah.
Init. Okay, so this is, I guess, setting up each ilk. So you pass in the bytes 32 for an ilk. There's an auth modifier, so you have to be authorized. Checks that it hasn't been initialized already for this given ilk. And then sets. Okay, so this is that. Is it a? What is it? Array with the 27 decimal places.
Yeah, looks like it.
Yeah. So it sets it to 1, I think. 10 to the 27. File. So you're passing in a bytes 32 what, and then uint data. I assume this what means the ilk, because identified by bytes 32.
Yeah.
Okay. So if what equals what? Line equals data.
What was the line again? The line was the total debt across the system.
Yeah, the total debt ceiling in the system.
So this is what allows you to set the debt ceiling.
If you Yeah, if the byte's 32, you pass in line, then you can
Oh yeah.
you can set the
No,
dead.
but else revert. That's the only thing you can do with it.
Yeah, true. Okay. Well, gosh.
Oh, but we have other files. Interesting. It's overloaded, so there is another file right underneath it,
Right.
which is
Yeah.
probably for the individual ones. It's probably the individual ones. Oh, right. Here we have more options. You can either pass in spot, line, or dust.
Nice. Okay, so then you're setting the like individual parameters per elk. Sweet.
Mm-hmm. It's interesting that they're using strings as bytes 32.
Yeah.
I seem to remember older Solidity naturally did not have strings. You had to use bytes 32 for strings.
I also seem to remember that. But
Something like Solidity 3 or something like that, Solidity 4.
is there also a gas saving maybe of using a byte 32 instead of a string?
It would not surprise me. That makes a lot of sense to me, actually.
I think that's the thing.
Strings are a dynamic array, for one.
Yeah.
Those are always expensive.
Sweet. So then we can set just individual parameters within an elk here. That makes sense. Cage. Okay, so cage is.
Pause. Okay, just pause.
I love the naming, dude. It's.
I hope they had fun. Yeah.
So we can cage the vat. That's cool. We can pause it. Fungibility. Slip. We specify an elk, a user, and a WOD, which is an int, not a uint, 256. And gosh, what is a gem? Yeah, so collateralized token for a given elk and a user. Okay, so you're just accumulating here, I think. You're adding. Is this debt? What's going on here? Gem elk user.
Sorry, I forgot I was muted. Not sure yet.
Collateral tokens. Okay, I think this is this depositing more collateral tokens? So you have like I guess an elk identifier, a user address, and then the uint, and then this slip function. It seems to be increasing the collateral that uint by WOD.
Probably could be subtracting also because it's an int, not a uint.
Fair enough. Yeah.
Don't be fooled by the add function. It might be adding negatives.
Yeah.
That's a guess.
Okay, so then there's flux. Are these things also like documented somewhere here? I don't think so.
Wishing there was some nat spec there.
Yeah. Oh wait, here we go. It's probably Flipper. No. Okay, never mind.
Nah, I have to look in VAT, probably. They don't have a VAT section.
Okay, flux. Specify an ilk again. Address source, address destination. So this is maybe a transfer kind of situation. And then some amount, which is a uint now. Wish. Is that was the approval, right? Or
I think so.
yeah.
Oh, it was the one that gives you the bool.
Yes. So either this is very similar to an approval but it looks like it's an infinite approval kind of situation. These two addresses are the same thing, so then you are approved to move your own, I guess, debt or collateral, or you have approved someone else with this can mapping. Sweet. So that's what it's checking here. Where are we? Where were we? Flux.
Yeah.
Yeah. So we're just checking that that the source address has approved message of sender, always the same thing. And then we have sub. Yeah. So there we go.
So what exactly is getting moved here, though?
This
I
is
see that we're
this is
this
basically
debt.
or a collateral. So it's the gem value, right? So where were we? Gem collateral tokens. Yeah, I think this is moving collateral between two like vaults. Um,
So then and we subtract it from the source, we add it to the destination, and life is good.
yeah,
Sounds right.
yeah. So this is just basically a transfer function. And I see. I mean, back in the day when I was following like urine finance quite often, I remember Bantig.
Back in the blue urine days.
Yeah, the blue urine, not the crazy green urine days. I'm not sure what's going on there.
Is it still green? I'm like expecting it to be something else by now.
Yeah. I remember Bantic kind of making a point that if you go low level enough and you're just interacting with Dai at sort of this function level, you can manipulate your debt in the system, like and bypass a lot of the gas inefficient stuff. So you don't have to necessarily use like the transfers or transfer from in the tokens, so in Dai or whatever, or go through there. They're more like user friendly.
I'll admit that I was thinking something like kind of a flip side to that, which is I'll admit I'm really shocked that this is all they need to do. Because you'd think there need to be some external calls, making some kind of transfer or doing something to something somewhere. But like literally just writes these two values and it's like, yep, we done.
We done.
So it could be this is being called by something else. There's no auth here though. So I guess it could be being called by a different contract in the system. And it could be that there are other places in the system where this is written.
Well, this is the approval. It's just like
right. You need to be approved by source, but you don't need to be approved by the contract.
Yeah.
Like it's not like an only owner or only system contract thing.
Yeah.
So yeah, that's surprising to me. Like, and I mean, I think that ties into what you're saying. That if you know the system well enough, there are probably a lot of massive gas optimizations you can make.
Yeah. So I think the urine guys were doing that for like
vault. They were fluxing the vat directly. Yeah.
Biting the cat and fluxing the vat. Yeah. Move. Source to destination again. Well, this is similar to this. What's the difference here?
Except that it's not gem milk. It's just the dye. So I'm assuming here you're moving.
This is collateral, and this dye is, I guess, what you're borrowed. This dye you've minted dye. So.
So is it transferred like the responsibility of the collateralization? Like if you're moving that source to dest, does that mean destination now has to have collateral backing this dye?
I think
like
so.
With Flux, I was fairly certain that if they move way too much collateral, so yeah, they'll just get liquidated on the spot. With Move, like I guess that's a way of. I guess that could make for good risk management also. You have a few different diversified vaults, and if there's volatility, you can move where you're borrowing your dye from around.
Yeah. But yeah, it does. Like, I really do. I'm wondering, like as you were saying, like, why are there not more checks, or why is it not sort of updating more?
How did they manage to do it that this is all you need to update?
Yeah. Because it seems pretty unsafe at this stage.
I wouldn't even say unsafe. I just don't understand how the bookkeeping works.
Yeah. Like, economically unsafe. So, yeah. I don't know. Because we're just moving, like, arbitrarily collateral in this case. And so maybe that sort of gives rise to the sin in the system.
Well, one of the interesting things about these two functions, about Flux and Move, is that the total circulating supply or total collateral doesn't change. It just changes who owns it. And I guess this is really the only piece. Actually, that is starting to click. if this is the only place that monitors who owns what debt and who owns what collateral, then this should be the only place you ever need to write to. But we should see a bunch of calls.
Yeah.
And that is that central contract in the ecosystem diagram.
Yeah.
And that's actually starting to make sense to me why Flux and Move you might be able to be more frugal with them than with other functions, since the supply isn't changing at all and you're just moving ownership of parts of what's already in circulation. Maybe this is the only place where you need to do it.
So here you can see, if we zoom out again, here are the functions we just went over. We've got like prob, flux, move, fork, and there's the CDP manager, collateralized deposition manager, and you can rely or deny. Those are those approvals.
We haven't seen frob or fork yet.
No, I don't think we have. Oh, we did see frob, but that was further down.
Briefly, I mean, we literally saw the words.
Yeah, there we go. CDP manipulation.
Mm-hmm.
All right, well, let's look at frob then. CDP manipulation.
Yeah, in a way.
Okay, so now they've given up on name.
IUVW. Oh, yeah. We've gone into the world of single letter variables.
That's fun. Okay.
Followed by a dink and a dart.
This is making our job so hard.
But at least entertaining.
Oh, no. Okay, so IUVW.
This is a complete troll comment, but I can't resist. I'm actually a little bit puzzled by the comment on 144. Like, they're being so frugal with what they write that, like, literally the simplest modifier in the book, they're like, but we need to explain this. The system is live. Like, and then it's like, earn memory, earns IU. It's just like, but you figure that out. That'd be simple.
Yeah. We don't need any NatSpec for IUVW, dink, and dart. That's all good. You know what that means.
Fascinating. So earns I and U. So that means bytes 32 is the identifier and U is the user. Okay, we've deciphered those two at least. Yeah, then we have ilk identifier. Ilk has been initialized, and again, for some reason, they love putting that comment. Very funny to me. Which they do by checking if the rate is 0 or not.
Maybe it's like a standard thing for each require. It seems to be the thing. You have to explain.
Oh, interesting. They explain the requires. Yeah. Nothing else. Yeah, you're right. That's it. You've cracked the code.
Yeah, the maker code. So, okay, I'm still. What is happening in a frob? That's. Does anyone know? Frob. Can I
there was
like
fork? I bet frob's around there.
Frob.
No, we will not explain the frob.
Okay, wait. I see something. Yeah. Frob functions. Okay, when you frob, you generate new die in the vat via CDP manager, which is deposited. Okay.
So it's essentially like minting more out of the existent vault.
Minting more, but do you deposit collateral in the same step, or is it just there is existing collateral? Oh no. Hang on. Anyway, I guess we can work that out. Okay.
We've also got this V and W that we haven't figured out yet.
Yeah. And dink and dart.
And dink and dart.
Oh, there's frob. Modifier vault. Okay, cool. So some modification. There's dink is a change in collateral, and dart is a change in debt. Bro. Okay. Oh my.
It's interesting to me also that here they're using ints. Like I commented before about the words, there were separate functions for adding a word and removing a word. But like over here, adding debt, removing debt, adding collateral and removing collateral are all being dumped into the same function.
Yeah. Yeah.
Now, I can think of reasons for that, at least, like why it would be, useful to put all of that in one function. It makes it a very, very versatile function. Let's say there's been market volatility in your favor and you want to mint more DAI off of the collateral that you have right now because now you're massively over collateralized. You could do that. Let's say you want to add collateral and mint DAI. You could do that. Let's say that you need to put in more collateral because of volatility not in your favor without minting DAI. You could do that. Let's say you want to take down the amount of DAI that you've got, et cetera, et cetera. Like, it happens to make it a very, very powerful function.
Yeah, definitely very versatile. But probably at the cost of being intuitive to just read and understand.
I think we've already sacrificed that by like having like the IWV, like whatever. But yeah.
We're long past that.
But actually, that being said, that was a bit of a troll comment because, like you pointed out, the code is pretty elegant. It's very simple. Like, I do hear what you're saying there.
Yeah.
Like, the variable naming conventions, I think, are like a different aspect of the readability.
They do make it fun. They make this like a whole...
Yeah.
It's like an adventure where you're trying to work out what's going on in a frob.
Yeah, go dink that dart.
Go dink that dart. Oh my god. Okay, so we've got ilk rate. What was this? Was this the debt? Oh, sorry, the cost of minting new DAI? Hang on, let me actually just go to the...
It was the total amount. It was the total amount of debt, I think. Total normalized debt or something like that.
Oh, it's a stablecoin debt multiplier, accumulated stability fee. So...
Yeah, but art itself is the total normalized stablecoin debt.
Oh, yeah.
So if you're minting more DAI, or if you're taking DAI out of the system, you'll need to change that.
No, yeah, I was looking at this at line 156.
Oh.
Yeah. Right. Cool. Should we get into these requires?
Yeah, let's do it.
Yeah. All right. So either debt has decreased or debt ceilings are not exceeded. Right. Yeah. So basically, if you're whatever you're doing to this vault, or to your ilk, I think, or earn, sorry, it should either decrease the debt or increase the debt, but not go beyond the ceiling. That's what's happening here. Earn is either less risky than before, or it is safe. Again, same sort of logic.
These are very interesting requires. Like, even just reading through the code of the require on 161. So they're using that either thing in the beginning to do those two things that they talk about there. The first half of it is debt ceilings not being exceeded. And then the comma is debt is less than or equal to line. As then that is fine. Oh, no, that's the one checking the debt ceiling. Either the debt is less than the debt ceiling, but you'd only need to check that if... Wait a second. Oh, it's checking three things. So either the dart is less than or equal to 0, making the dart negative. Oh, that's the first one. Okay, the first one, it's you've removed debt.
And then there's a both.
And then you have, that's a both. Yeah, got it.
I kind of like this, actually, this whole either and both thing. I think it might even be more readable with the ors and operators.
Yeah, I actually do like it.
That's quite cool. Sweet. Okay, same sort of logic here. We're just checking this like a concept of safeness. Tab, I guess that's what measures safeness.
It was there in the function. I'm pretty sure it's in Frob.
In Frob. Ooh, that's just actions. Tab. Oh no. Okay. C tab in byte. Okay.
You're in events.
Yeah.
I don't know if that's what you want.
Okay. Right. Anyway. Let's go to this one. So earn is either more safe or the owner consents. Okay, so to become unsafe, I guess you become more unsafe. This is probably like
more unsafe is more die to the same amount of collateral, most
taking
likely.
on debt, some sort of measure of like collateral ratio is getting more risky. So it's interesting that can someone could like repay your debt or whatever and make it less risky without any sort of approvals. But I guess if they are borrowing against your position and making it more risky, then they need approval or consent here.
Mm-hmm.
Collateral source consents.
Why am I not able to just mutilate die by sending in like a negative? Which one was it to remove debt? Like sending in a massive negative and just like taking die out of circulation over here. Oh, that's the debt DST consents. I think that's the next one.
Debt DST consents.
Either dart. Yeah, so I was wondering why you can't put in a massive negative dart for kicks. But you're going to need wish between whatever letter that is, think W, and the sender. And this has to be those other two addresses, the W and the V.
Yeah.
One is the like whoever's in charge of collateral, and one who's I still don't get exactly what they are, but like I can figure out that much of the context. That W is the one who stands to lose if the amount of die goes down, and V is the one if the amount of collateral goes down.
Yeah, that makes sense. And then last require is earn has no debt. So yeah, I'm just checking that the debt is either 0 or it's more than there's like that sort of small dust amount left in the urn. That's interesting. Why would we not want to operate on a dusty amount of debt?
I'm not sure. I was wondering the same thing. Not allowed to leave dust in a vault, maybe? It's a dusty amount of debt. Oh, okay. I think this is probably one that's like 60%, right? But I think in terms of being 60%, right, we wouldn't want there to only be a dusty amount of debt because it'll never get cleaned up. No, it's not worth it for anybody to liquidate. So no one's going to ever bother for it. So it just ends up being kind of like just debt that just sits there.
But it's weird to sort of like just enforce that in the system. Why not just let the economic principles decide that if someone wants to spend the money or the gas?
I'm assuming it's because they just want to tie up loose ends, but I also suspect that's going to be part of the reason why what I'm saying is probably only around 60%, right? I think 60 is even giving myself a little bit too much credit. It's probably not 0%, right? But I'm not going to a percentage there.
And then we sub the gem by dink, and we add the die by dtab. So we dink the gem.
Dtab isn't a word. Come on. Should have been more creative. They out of like 4-letter words or something.
And then this is again just a good gas optimization, doing your manipulations in memory objects and then writing them back to storage at the end. You can see we over here we load them into memory and we do our manipulations on them. Earn an ilk. Yeah. Yep.
It's also for reading because we read off of it also.
Yeah.
Gotta get the loot.
Okay, should we keep going?
Yeah, we started a bit late, so we'll probably run a bit late. So yeah, we doing some.
We can do 4. To split a vault, binary approval or splitting merging vaults. That's interesting.
That is interesting.
And then there's wishes. We've already gone over wishes. Is basically an allowance approval thing. So Frob is modifying a given vault, and then fork is either like what, merging or splitting vaults.
Yep.
Okay, cool.
I would have thought form with an M would be better than fork because it should represent both the idea that you could form two together, but they didn't ask me.
No, don't you put in a PR for that?
So again, bytes 32 for the ilk, the source, destination, the dink, and the dart. Just have to see how we're going to use the dink and the dart here to either split them apart or merge them all together. So we load a UV and I, so an urn, another, and an ilk. I'm assuming U is for urn, V is because it looks kind of like a U after it, and is also an urn, and then I for ilk. Yeah, so then we have the U.ink, the U.art, V.ink, V.art. And like you were pointing out, these are all going to be... Oh, wait. No, we'd be doing this in storage.
Yeah, I did see that. I'm not sure what the decision is there. Interesting. Yeah. Why? Chat. Do you know why the storage?
Oh yeah, go for it.
Yeah, I mean, Will and I think, are both thinking the same thing here. Why create these objects and like point to storage when we're going to be doing some modifications, some manipulation on them to be more gas efficient to... Yeah. We're doing a bunch of reads as well in all of these requires. We would think it would be more gas efficient to do that in memory than storage.
Memory.
Maybe it's the like inefficiency of bringing such large structs out of storage, because each slot in one of these in an urn would be its own like S load. Maybe that cost outweighs the cost of reading and doing writing to individual.
A lot of writing. That's 4 writes right there. Just in that little thing.
But like, well, it's it would be one, I guess, 4 S stores, and then some.
But it's worse because then you've got all the S loads in there also. It's 4 S loads and 4 stores.
But instead here, I mean, you would have to S load each component of the urn.
You're saying you're S loading it anyway. I hear what you're saying. So you're saying that's not a loss.
Well, so
yeah, your math is probably that math is probably going to come out that way. That all of these loads put together aren't any worse than just loading it once. Yeah, probably something like that. I'll admit, I've discovered I'm very, very bad at figuring out when memory is better in storage and all of that. I need to get a little bit better, just like building up a better intuition for myself about memory versus storage on these things. Like when loading the entire struct in memory and then writing it to storage is cheaper and like all of that.
Yeah, I think that's something I need to do as well, is be more careful of like the size of the thing I'm loading or storing versus not always just defaulting to memory, and just, maybe it is more efficient to do it in storage if you're going to pull out a whole huge struct that you're not really going to need. Sweet. Do you want to keep going for these requires? What are we doing here? We're forking. We're either merging or splitting a vault.
Yeah, I am starting to get this. It's interesting. Source and destination here are actually a little bit misleading because, again, we're dealing with ints, and you could just be putting in negative numbers in which case that would kind of be different than, like, that would basically move it from dest to source instead of source to dest. Was that gibberish? I can explain that in more words.
Yeah, maybe try again.
It was gibberish. Okay, so at least me intuitively, I would think that the funds are flowing from the source to the destination address. But since we're dealing with the ints, that can be counterintuitive.
Yeah.
Like, you could be moving funds from the destination to the source because you subtract from the source and add to the destination. But if you're putting in negative numbers, then you will be subtracting a negative number, i.e. adding, and adding a negative number, i.e. subtracting.
That makes sense. So, but then, yeah, would you need to watch? Yeah, both sides consent.
Yeah, it's interesting that they didn't do the whole mess that they did by frobbing also. They just kind of assumed both sides are going to need. Because collateral is, I mean, I guess it's uncommon that they would just be moving collateral from one to the other, or just debt from one to the other, and only one side would need to prove. I guess that's just the assumption here. I mean, theoretically, you could use this for this, but if like it was saying before, the idea is either split into two or to merge all funds into one. So then both sides will be taking on some kind of something approval.
Yeah. No, I see what you're saying. But I guess they've accounted for that. Or maybe they're also accounting for it and just checking that it is greater than 0. Think and dart. Both sides non-dusty. Yeah, do you want to go into grab as well? What's this? Confiscation. Settlement. Heal. Suck. Rates. Fold. These are auth functions, so you have to be authorized to call them. Same with grab. You can confiscate. Okay, so the system actually, you have, like, I guess, authority to confiscate people's collateral. That's interesting.
It's adding dink to ink.
But dink
and dart to art.
But dink is it could be negative again.
Yeah. No.
Yeah, and then they do a sub here with that's so odd.
Yeah, the use of ints in some of these is a bit interesting to me.
Yeah.
I wonder if there's like a specific design reason for it. Right.
Sweet. I think we've gone quite a bit over time here. So we do have meetings and actual work and just 4 and 3 letters. So, yeah. Well, thanks, Will and Rory. This has been, like, actually super fun going through the Maker code base. Like, definitely want to get to the rest of it at some point. This has, like, been quite a fun code base to go through and, like, have to piece things together with this glossary. Yeah.